Yeah, thank you.
Thank you. So we will have Professor Diomar Lobao from the University Federal Fluminense of Brazil. He's going to talk about a linear new approach for trigonometric inverse series applied to Newton method.
Yes, I thank you
So you have some noise, Professor. Maybe, I don't know if...
We are under heavy thunderstorm right now with lightnings and everything that you
Okay, it's okay. Go ahead.
Okay, so first of all, I would like to thank you very much to have me in this meeting and allowed me with this opportunity to present this simple work, but has a deep impact in numerical analysis. The title, as you said, is a linear new approach for trigonometric inverse series applied to NewtonRaphson method. As you said, I am a professor at the Universidade Federal Fluminense in Brazil, actually in Rio de Janeiro city. So the motivation about this work is based on this original work by Kumar, Tota, and Kumar too. When I read this paper, I had some question in my mind. One of them was, could another different functions based on trigonometric evaluation be also possible to be applied for the transcendental equation based on NewtonRaphson method? And after a little research, I find out that not only seeing those sinus functions as these three professors did, their work is possible to be applied, but also inverse tangent and inverse hyperbolic functions too. So that was the main motivation. The secondary motivation was, okay, with this approach, we are also able to make the NewtonRaphson method a little bit more simple. Although everyone knows that the NewtonRaphson method is a very simple method and highly efficient method. But with the idea of interpolation, as I am going to show, we are able to write in a very simple linear form. That was the secondary motivation. The new proposed algorithm is based on a combination of inverse sine series and NewtonRaphson method. The purpose of this article is to show that not only can the inverse series sines be used to approach the NewtonRaphson method, but also the inverse series of the tangent as well as the hyperbolic sine and the hyperbolic tangent. So these representations result in the new proposal to formulate the NewtonRaphson method as an approximation through a linear interpolation function. Numerical simulation showed that the present proposal provides excellent numerical results. So the main idea was use the inverse tangent, because the original work they use inverse sine function. So that is where we are going to establish the main purpose of this article. Expanding the inverse function tangent in power series in the iterative formula, we are able to obtain the standard NewtonRaphson method. Let's state the following theorem. So this theorem helps us to show that also the tangent, the inverse tangent function, can deal with what we are trying to prove. So the first one, the first linear interpolation approach, we use the function series, power series for inverse sin, and after we have the power series development function for inverse tangent. We can have this x in the interval of less than 1 and greater than minus 1. So it's possible to show, as can be seen in the figure 1 of the article, a narrow linear behavior in the interval -1 to +1. This is the figure 1. So both functions, inverse tangent and inverse sine, whatever, have a very narrow gap between more or less -0.4 to +0.4 as a very linear variation, as we can see. So we observe in figure 1 that the narrow interval from -0.4 to +0.4, the two series, has a similar behavior, showing that there is a numerical gap between the two, since they are not the same. If we put the zoom function from MATLAB, for example, we can enlarge this region. So in this situation, they look like they are one over another, but there is a gap. The relation in the iterative process tends to 0 in order to work the NewtonRaphson method. The relation, I can go back a little bit just to show. This is the relation. Minus f of x power n divided by x power n multiplied by derivative of f evaluating x power n. So that is the relation which I am talking about here. So it is possible to fit a first order polynomial to each curve in the interval -0.4 to +0.4 and rewrite the original NewtonRaphson method as this equation, which is in the linear form. So by least square method, we can fit for different series, for example, like sine series and tangent series, we have different a and b coefficients, and just apply the method for a given xn, x power n, as an initial condition. So that is the main idea of the whole work. Some reference, not all, but partial reference. And thanks. Obrigado por listening.
Thank you, Professor Lobao. ¿Hay alguna pregunta? Is there any question for Professor? ¿Alguna pregunta? ¿Alguna persona? Professor, I saw in the last result, can you go back to slide that maybe 11?
Which slide?
Yes, that one. So
Sorry?
the next one, 11.
This one?
No, 11. Go to the two more. There, okay. So I see that B in this case is 0, right? So you need this.
Not exactly. It's almost 0 because
Okay.
it's e power minus 18. Almost.
It's almost
For
0,
both,
yes.
For both of them, for the sine series as proposed by the three authors, which I commented before, and also very small for tangent series.
Yes. So you, in this case, you almost don't need this B parameter, right?
Well, I am not quite sure about that. Depends on the precision of the results you are looking for.
Okay.
Maybe for a very high resolution, like for example in the limit of the numerical results for the MATLAB, which give us e power minus 14, for example, maybe cause some damage or not. We have to look for this, if this is a big issue.
Okay. So we have a question from Anthony. He's asking if you work with some variant of the Newton method with some fractional derivatives. Did you try some variations of this Newton method using fractional derivatives? Or?
Well, I have the full version of this article, and of course I couldn't submit it because we had the limitation 4 pages, you know. But I also did numerical experiments with different nonlinear functions, and also for hyperbolic functions, to inverse hyperbolic functions. All of them work very well, even based on this first order polynomial interpolation.
Okay.